All right, so question 3 here. You find that your brownies are really good, they're really delicious, right? And in one grand stroke of inspiration, you decide to start selling them online. And before you ask, yes, all these questions are on theme. Took me a while to write them this way, but it was a lot of fun. I enjoyed doing it. Let's talk about the question at hand, though. So we've now defined this function b of c to represent the number of brownies we sell when the price is c dollars, right? So this question is very familiar. It's very similar to the one we talked about in the previous video with the robots, right? So let's not forget that. Okay, so now let b prime of 3 equals minus 2. How could we interpret this? So this is something you should be getting really good at right now. So remember, this guy right here represents this is the instantaneous rate of change of b, of the function b, right, at c equals 3, and this tells us that this is minus 2. So that's, in the strictly mathematical sense, that's what this is telling us. Now let's go ahead and just put some words and units to this to make it sound a little bit more understandable in common terms, right? So what this is saying is that, okay, so when c equals 3, or in other words, when the price, right, is $3, when c equals 3, we can say that the number of brownies we sell is decreasing at 2 brownies per dollar. Awesome. So a few points to note out here. So firstly, you want to make sure you always have these units here, right? So for the units of c is dollars, so you want to have that in there. The units of the derivative of b prime is brownies per dollar, right? I didn't explicitly ask you for that up front, but that's what it is. You want to have those both in there, right? Easy points. Next thing I want to mention is notice that this number is positive here. This 2 here is positive, but it's minus 2 here, isn't it? Well, the reason it's positive here is because I use the word decreasing here, right? I use the word decreasing, and remember, the word decreasing carries an implicit negative sign, right? So by writing decreasing, I have to keep this thing positive. You could also write this as changing at minus 2 brownies per second. Both of those mean the same thing, but again, just be very careful about the words that you use here, right? I know it sounds very picky, but again, you just want to be very careful with that, right? You don't want to lose points over something that small, right? Awesome. So just be careful with that. And next question here. So this guy is now asking us, let b of 3 equals 20, right? How could we interpret that? Well, b of 3 is not even asking us about the derivative, right? It's just asking us about the original function. So we can just go ahead and just put that down, right? So we know that b of c tells us the number of brownies we sell for this price. So that basically all that's saying is that when the price is $3, we sell 20 brownies. Okay. Not strictly a calculus question, but sometimes I've seen AP questions where that's thrown in there just to make sure you know exactly what's happening, right? So that's that. Next piece here. Approximately how many brownies would we sell when the price of a brownie is $3.50? This one's a bit of an interesting one, so stay with me. So we don't actually know what the function b of c is, right? Because really what this is asking us for is it's asking what b of 3.5 is. Okay, this is what this is asking us. We don't know that, right? Because we don't know what b of c is. We don't know what that function is, so we can't just plug in 3.5 and get something. However, notice that this question is asking us just for an approximation, right? We want to know approximately how many brownies we might sell. So we have a little bit more flexibility now. We don't need an exact answer, we just want to estimate, right? So let's see if we can use any of this previous information here to our advantage. Well, we know that it's probably going to be close to b of 3, right? Because 3.5 is close to 3. It's probably going to be close to b of 3. So let's put that in there, right? So we have this 20 here. And now notice here that what does this thing here tell us? Well, that tells us, right, that when the price is 3, the number of brownies we sell is decreasing at 2 brownies per dollar, right? So in other words, what that's telling us is that if we were to change the price ever so slightly around this $3 mark, maybe $3.50, $4, even $2.50, something like that, the price would approximately change, or let me just circle this, the price is approximately going to decrease at 2 brownies a dollar, right? Let's throw that in there now, right? So we're going to decrease by 2, right? We're decreasing by 2, but exactly how many cents or how big is this what do we multiply this to by? Well, that's going to be this extra 50 cents here, right? Because remember, we're starting at 3, and then we're interested in 350 though, so it's going to be 50 cents or 0.5. So it is going to be 3.5 minus 3, right? Which is 0.5. So I hope you see where each piece is coming from, right? So we know that b of 3 is close to this. So we're starting at 20, and then we know that around b of 3, the price decreases at 2 brownies per dollar, right? So then we tack on that minus 2, and then we multiply by the difference of these two things, right? 3.5 minus 3. If we flesh this out, we would get 20 minus 1. So we know that this is going to be approximately 19 brownies. And again, I want to stress, this guy right here is an approximation, right? This is an approximation. It's not an exact answer. So it's just an approximation. Really good approximation, but an approximation nonetheless, right? Now, one thing you might see this actually looks pretty familiar, right? Because this guy right here is b of 30, right? This is b prime of 30, and this is w minus 30, w minus 3, right? Because w is 3.5. So this right here is actually a linear approximation. So what we've actually just done here is a linear approximation, right? All the pieces are exactly the same as we used with linear approximations, right? The only thing is we just interpreted it a little bit different this time, and we're applying this to a real world problem, right? So that's how this example works. If you found this video helpful, please do like, share, subscribe, leave a comment, and check out some other videos. See you next time.